very much for the introduction, and thank you, all of you, for being here today, especially to the Samir. So, my name is Angel Lanza. The title of the presentation is Fluid Dynamics in Large Flow Reactors, Experimental and Modeling Study, and Dr. De Laza is my advisor. The agenda that I'm going to be following today is represented in this slide. I want to start with the problem description. I want to explain the motivation and why I did that research. Then I will go through the objective. I divided the presentation into two parts, experiments and modeling. And finally, I want to show the results and conclusion. So let's start. Circulating fluidized beds using risers has been implemented in large amounts of process nowadays in industry. So the main feature is that the fluids go through the riser one time, while the particles circulate in a closed loop many times. So as an example of the application of circulating fluidized bed, we can find the production of gasoline in the fluid catalytic cracking, in the combustion of coal biomass and waste in power plant for power generation, in the Fischer-Tropsch process for the production of synthetic oil and synthetic fuel, in the production of malic anhydride, that is an organic compound used to give superior properties to polymers that have been used in the automobile industry, in the boat, recreational boat production, and bathroom fixture. We can also find circulating fluidized bed in the carbon dioxide capture to mitigate the emission of carbon dioxide to the atmosphere. So as you can see here, circulating fluidized beds are very important nowadays. So when we look into the riser of the circulating fluidized bed, we notice that everything goes up against the gravity. That's why risers present a major problem, that is a back missing effect in the near world. So I dedicated my study to a solution that can be used in circulating fluidized bed. And that solution is the application of a downer. So in the downer, everything goes down in the same direction as gravity, and that's why the profile is flatter. And that's very convenient for some processes. So in the downer, the main advantages are homogeneous direct flow structure with benefit selectivity, near profile of phases with narrow the residence time particle inside the reactor, short residence time because the back missing effect is not there, and we can load the reactor with a large ratio between the catalyst and the fluid. So, having said that, the downer has potential application in processes that require short and uniform residence time distributions. And as an example of that process is the gasoline production. So the gasoline is an intermediate product where selectivity is important and reactions are very fast. So in 2004, Abdul Hamayer did a pilot plant study comparing downer and riser for FCC application. And what he found was that when comparing with similar operating conditions, in the downer, a 22% higher amount of gasoline was found, with a lower amount of coke and 32% lower amount of catalyst needed in the unit. So these results are very promising for the application of downer in industrial processes. Now let's talk about the objectives of my research. So the general objective is to study the hydrodynamics of the gasoline flows in the downer to contribute to the design of downer reactor at industrial scale. So the specific objectives are the following. Individual